So today we'll be starting our next chapter in our textbook, and this chapter is called Extending Calculus. So basically, we've looked at the basics behind differentiation. We know how to use the chain rule, the product rule, quotient rule, and we've explored a little bit about rates of change. But now we're going to start looking at calculus in terms of other types of functions. So, namely, we're going to be doing a little bit with exponentials and logarithms. So this chapter is actually split into two main parts. So the first bit we'll be doing a fair bit with exponentials and logarithms. In part two, we're going to be doing a little bit more with trigonometry. So these are the two main sections that this topic sort of encompasses. So this first section, we're looking at the exponential function of base e. So I spoke very briefly about this when we were looking at exponentials earlier. So e is a special number. It's an irrational number, but there's special ways in which we define it. So we know that back then we said that e is approximately 2.71 thereabouts. So it's a number between 2 and 3, and it is an irrational number. The reasons why we have this number are going to become a little bit more apparent when we start looking at calculus, when we start looking at the significance of this particular value. So for this first section, it's just an investigation. So in the Google Classroom, I've linked you a GeoGebra file called Investigating E. And basically, we're going to look at why it's important to know this value of E. So what we're going to do is we're going to fill in this table using this information. So what I'll have there is you're going to have graphs of 2 to the power of x, 3 to the power of x, and e to the power of x. And what I'd like you to do is find the value of y for each of these x values, find the value of m, or the gradient. Now, if you have a look at the Investigating E applet, what you can see is this is what it looks like. So what I've got is I've got the 3 different graphs here. Don't have them all open at once because that's going to be a bit crazy. So you're going to have a look at them one at a time, and you're going to be looking at the y value at the point and also at the gradient. Okay, so at the moment, my graph is at 0, x equals 0. I can move it across, and then I can get x equals to 1. So you can see the y value has changed. It's now 2. The gradient is 1.386. And what you want to do is just look at each of those values, write down what the y-intercept is, the y value, y coordinate, and write down what the gradient is. And then what we want to do with this is we want to start looking at different patterns, okay? So I'm going to leave the tables for you to fill in yourself. But just quickly, if we have a look at these values, the y value over here is 4, and the gradient is 2.77. If I have a look here, the y value is 2, the gradient is 1.38. So you can see the gradient number is always smaller than whatever the y value is. If I change to the graph of 3 to the power of x, what you can see now is if I'm looking at this number, this point, the y value is 3, the gradient is 3.295. So what you can see there is the gradient is bigger than the y value. And then so that sort of makes us think, okay, so if it's 2 to the power of x, the gradient's smaller than the y-intercept, y value. If it's 3 to the power of x, the gradient is bigger. So is there a value where the gradient is the same? And that's actually where e comes in. So if I have a graph of e to the power of x, what you can see there is the y value is the same as the gradient. And that's going to be really important when we're looking at gradient and calculus in terms of differentiating and integrating exponential functions, because e is going to be a special one where it's going to be really easy to calculate with. So what I'm going to do is I'm going to get you to fill in these tables yourself. Okay, you should be able to just move that slider back and forth in order to work out those numbers, and then you should be able to answer this question because I've sort of spoken about this already. So that's for you to do. So using that, we can now say that if we're looking at the gradient of a tangent on an exponential, if we're looking at e to the power of x, the gradient is the same as the y coordinate. Or in other words, if I differentiate e to the power of x, we're going to get e to the power of x back out, okay? Because y equals e to the power of x. So that's going to be a really special relationship that we will be using. We'll be using this a lot more in our next lesson rather than in this lesson. So what we're going to look at is just how we can go about finding this e. So e is also called the natural number, okay, because it's sort of like a naturally occurring number. It is on your calculator in two places. Now those two places are, let me get a calculator up. Those two places are up here, okay? So if you have a look, it's a bit blurry on my screen, but that number there should be E with a little box on top of it. So if you press Shift and then LN, then you will get E with a little box. So it's going to be E to the power of. So what you can do is you can use that in order to get your E to the power, and then you can put in whatever power you want. So that's the first place you can see it. The other place is actually down here, over here, if you can see, and it's in red. So it's sort of like next to your pi button. So it's on the 10 to the power of x, and it's in red, which means you're going to use the alpha button. Now this one will just give you e as its individual value. Okay, so if you want to multiply it by something, then you have to press times. If you use this one and then you want to do a power, then you'll need to press the power button in order to get the power. So with these examples, firstly, we're just going to be calculating each of these values. Okay, so it's just a calculator lesson. So what you're going to do is on your calculator, for the first one, because it's just e, what we can do is we can press alpha here, and then 10 to the power of x, and that's going to give you an e, and then you press equals, and then the answer is 2.718 something to two significant figures, 1, 2, cut it off, is 2.7. If I want e cubed, what I would do instead is I'll press shift, then the ln, and then I can just press 3 equals. And that will give me e cubed. And that comes out to be 20.0855, or to two significant figures, that's going to be 20. If I want the square root of e, what I can do is I can use the square root button right there. So I can go square root, and then I'll use alpha e equals, and that's going to give me 1.6487. Oh, that was really bad. 87. And so to two significant figures, it's 1.6. If I want e to the power of -4, I'm going to use the yellow e and then put -4 in. That comes out to be 0.01831 something. So two significant figures, remember first non-zero digits, that's going to be 0.018. And if I want e to the power of 0.1, same thing, we're just going to put 0.1 into the power, and that's 1.10517, or to two significant figures, it's 1.1. So that's just a calculator exercise. Hopefully you're okay with finding those values on your calculator. Be very careful with significant figures. Make sure you know how to round these numbers off. Now, the other thing that we're going to look at in this lesson is graphing y equals e to the power of x. So we're graphing exponentials. We've already done a lot of these before. So an exponential looks like this. We've got the x-axis is an asymptote, and it passes through 1. So that's your basic exponential graph, but then we can do transformations. Remember, left, right, up, down, flip over, those sorts of things. So let's have a look at these ones. So graph e to the power of x and its corresponding transformation. So we're going to draw both of these. So e to the power of x, okay, it's just an exponential. It's going up this way. There's your y equals e to the power of x. Now, when we're looking at the equation, we've got e to the x plus 3. That plus 3 is on the outside, so that means we're going to shift this graph 3 units upwards. So that was where 1 was. So we're going to have an asymptote at y equals to 3, right there. It's going to pass through 4, and that's going to be y equals e to the x plus 3. Okay, so we're shifting it 3 units upwards. With our next equation, y equals e to the power of negative x. So let me start with e to the x first. Y equals e to the x. If I've got a negative inside of the x, that reflects it across the y-axis. So that means that y equals e to the negative x is going to look like this. It's going to go in the opposite direction. Because basically what that means is if I had a positive x value, it's now turning into the negative. Okay, so it's turning into that one there. Okay, if I have a negative x value, then it's turning into the positive one over there. So this is going to be y equals e to the minus x. With our last one, again, start with e to the x. Now, if I've got the minus 2 inside, that tells me I'm moving it 2 units towards the right. Okay, so 2 units right. So if I'm moving 2 units to the right, then this point here is going to go 1, 2. It's going to turn into that one there. And then everything is going to move over by 2 units. So this graph is going to do this. What we might want to do here, so that's going to be the value 2, 1. What we might want to do here is we might want to find the y-intercept. So if I substitute in x equals to 0, that's going to give me e to the power of negative 2. Okay, so that would be the y-intercept of this graph. Again, asymptote is still the x-axis here. Asymptote here. Okay, so hopefully that's a little bit of a review of how to draw graphs of exponentials. Basically, if we're just drawing a sketch, then e to the power of x won't look too much different to 2 to the power of x or any of those.